Okay, so what we're looking at right now is a chart that I use to help students figure out how to get a good Lewis structure, which is going to be in column 2 of this little chart. And what we're doing is we're setting this up so when you're done, if you have any idea what this stuff means, you'll always be able to check and be absolutely certain that your Lewis structure is okay if, when you do a check, you have the check for 8 electrons for every atom except hydrogen, beryllium, and boron, and that the total number of electrons is always going to be correct. So let's get started with the hydrogen, and what I do is draw the Lewis structure with one bond between the atoms. So that's what we have here. Now, we want to be sure that we have the correct number of electrons, and so the way we do that is we put in the name of the atom, and then we say, well, how many valence electrons does hydrogen have? 1. Okay, how many hydrogen atoms are in the molecule? 2. So it's 1 times 2 is equal to 2. Now, so 2 is the number, and that's what we want for this particular molecule. And I'm going to get the shade back up so it's a little easier to focus. And now, once we have this 2 here, we go back over here, and remember that this little line is meaning 2 electrons. So this guy has only 2 electrons, and now I can go and put a check here and put a check here. The first check was to make sure that from up here, see, everybody has 8 except hydrogen, which has 2. And then the total number of electrons was correct according to this number right here. All right, let's do another one. It's just a matter of practice, folks. It'll take you a few, and then it'll start to make sense to you. So how many nitrogen atoms do I have in the molecule that I'm going to do next? 2, okay, because of that 2 there. So let's put our 2 nitrogens in, and I'm going to get rid of these guys for right now. And we're putting in 1 bond, okay? That's going to be 2 electrons. And those others I'm going to save for later on as we go through the logic of how to get this guy right. First job, nitrogen. And how many nitrogens do I have in the molecule? 2. And how many valence electrons does nitrogen have? 5, because he's in column 5. Okay? Column number gives you the valence electrons. So we have 2 nitrogens at 5 electrons each. That's valence electrons only. And that gives us a total of 10 electrons. So the next thing I do, if I haven't already got all the electrons I need by putting the bonds in like I did for hydrogen, now I'm going to look at this guy and say I have 2. How many more do I need to put in? Huh? 10. Okay, 5 came from each of these guys, and it doesn't matter where they are. Okay, so I have 2 already. Now I have 4, 6, 8, 10. That's all I have. 10 electrons, and both atoms have to be able to share or have on their own 8 electrons. So, what am I going to do? I'm going to go looking for electrons that I can borrow, because I got to get this guy on the right some more electrons. You see it here? This poor guy is crying the blues. How many electrons does he have right now? Got to count the ones that he's sharing. Yeah, so this counts as 2, and this counts as 2. So now I look and I say, well, where can I give more to either give or share with the guy on the right? I can take these, it's like magic. It goes away, and then it comes back. Come on. Oh, you're tricky. Here we go. Come on. Come on. There we go. All right, now we got them in the bonding. So, do I still have 10? Let's count them. 2, 4, 6, 8, 10. 10 is the total. Now, how many electrons does Mr. Nitrogen on the left have? 2, 4, 6, 8. And how many does nitrogen on the right have? Yeah, 2, 4, 6. Just let your mind relax a little bit and just watch, and you're going to find out that you'll have an aha moment here pretty quick. Okay, so I'm going to do my magic trick again. I'm going to get rid of these guys, and I'm going to take this dude and put him in here because that replaces my 2 electrons that I just got rid of. And now, let's work it out. 2, 4, 6, 8, 10. Now I'm counting the total electrons to make sure I have that number. That's what that column is for, reality check. Okay, because you tend to just want to put electrons where they need to be. So you can't do that. You have to just deal with what you have. So let's check nitrogen on the right. How many? Come on, what's that? 2, 4, 6, and 8. See, if he's touching the bond, he gets to count the electrons, right? All right, let's look at our other nitrogen. 2, 4, and 8. Aha. So, I have 10 total. We've already checked that. And my second check is to see, oh, that was the second check, to see that we have them all. But we have to have 8 for everybody, and that was the last thing that we did. We checked that everybody had 8. And now, we have ourselves a bona fide, good Lewis structure. And we can build a molecule kit from that. Or with a molecule kit, we can build that molecule. So did you get the idea here? If you need more, you've got to share. That's what you just learned. And it wouldn't be bad if you need to share, if you need more, you are going to need to share. So if you need more, you need to share. Need more, need share. Keep it short and sweet. So if we share, we're likely to get ourselves a good structure. I'll just leave that right there as we do this guy. Okay, it's obvious from here. I think you all understand now. That's where we tell how many electrons we're going to have in the structure, or how many atoms, I'm sorry, we're going to have in the structure. And so we have 2 sulfurs. We put them together with 1 bond, and then we have to check and see how many total electrons we're going to have. So sulfur, how many do I have in the molecule? 2. And how many valence electrons? 6. So the total is 12 now. I'd like you to go ahead and work this on your own and turn off the recording right now and see if you can get it on your own. That's the way you learn the best. After getting this started, we wind up with having to put in more electrons. Because I should have a total of 12, I'm going to add 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now, after I have all the electrons in place, and my first atom has 8 electrons, the one on the left, okay, this guy, he can share now and still have 8 electrons. Isn't that true? Yes. If he shares. Okay, so what he does is he puts a bond in here, and we take these guys away, and now sulfur on the right has 2, 4, 6, 8. sulfur on the left has 2, 4, and we count these guys again. 6, 8. And now, okay, the sulfur now on the right has 2, 4, 6, 8. The sulfur on the left, 2, 4, 6, 8. And then, remember I counted these bonds for both of the atoms. That's why that happened. But now I want to count the total number, make sure I still have that right. My total should be 12. So it's 2, 4, 6, 8, 10, 12. And now I know that I have a good Lewis structure. Okay, in our third example, we have sulfur dioxide. So we're going to have sulfur and 2 oxygens. Now with this guy, you need to learn one extra thing. Oxygen has a lower electronegativity than does sulfur because the electronegativity increases as you go up a column. And the guy that we want in the middle is going to be the sulfur. Okay, this guy right here. So if we put sulfur in the middle instead of one of the oxygens, our molecule layout is going to look like this. The next thing we need to do is put bonds in. And so I'm going to write those in. I'm not going to be too fancy like I was earlier. And I'm going to give everybody one bond between each 2 atoms. The next thing I want to do is figure out how many electrons I'm going to have so I know how many more to put into my structure. So I'd like you to figure that out. I'll stop the recording and you stop it too and figure out how many electrons, according to the pattern I gave you, are going to be in this Lewis structure. Okay, if you just restarted your screen, you'll see that I added check marks up here because I did the checks, but I forgot to put them in the check boxes. So let's go on now. I hope you calculated your total number of electrons this way. Now the next thing you need to do is put in the extra electrons that you don't have in these bonding electrons. So we have 2, 4, 2 for each of those bonds, and we subtract 4 from 18, which is our total number that we should have, and that gives us 14 more to put in. So here we go. I start with the atom on the left and give him enough that he'll have 8, and then I go to the sulfur in the middle, and so on. Watch how we do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have 11, 12, 13, 14. Now I have all the electrons there that I should have, and that number is here. So I look over here and I say 2, 4, 6, 8, 10, 12, 14, 16, 18 total. So I got the right total. Now I have a problem with my oxygen on the right. He's short electrons. So I could take electrons from sulfur that would make him very, very happy. And so what I'm going to do is put another bond in, and when I do that, I'm going to have to take out 2 electrons from the sulfur. Whether I take them from the top or the bottom, it really doesn't matter. So I'm going to take these 2 out. And now I check again to see if I have my totals right. 2, 4, 6, 8, 10, 12, 14, 16, 18 total. So with 18 total, do I have 8 for everybody? Now we've got to check that. Okay, our total is correct. And remember from up here, the total is our first check. So I'm going to be able to check that off. And now I want to check off to see if everybody has 8. 2, 4, 6, 8 for this oxygen. 2, see I'm counting these again, aren't I? 2, 4, 6, 8 for the sulfur. So these are unshared pairs and these are shared. Okay, each of those represents a pair. So that sulfur's good with 8. And I count this bond again for the oxygen, 2, 4, 6, 8. And everybody has 8. So I now have another good Lewis structure. Okay, let's do this last one. This is kind of an interesting one because now you have 4 atoms around the central atom. Okay, with 4 atoms around the central atom, we've got to put in bonds very first thing. 1, 2, 3, 4. Now our Lewis structure is knit together. And carbon is in the middle because it has a lower electronegativity than does the fluorine. So let's look at the electronegativity trend again. Those of you in my class, this is review. For some of you not in my class that don't know about this, this is the trend for electronegativity. I'm going to abbreviate that electroneg. Now, I look here for where carbon is on the periodic chart. Carbon is off to the left a little bit. This is where carbon would be. Let's get that up and try that again. Okay, carbon is up here, and fluorine is on the same level over on the right. If you look at the periodic chart, you'll see that that's the case. Carbon is element number 6, and fluorine is element number 9. So, we now say because the trend for electronegativity is it gets bigger because of this guy, see that arrow? It gets bigger going from left to right. So carbon is the guy that has to be in the middle. And that's why I put carbon in there and not one of the fluorines with carbon on the outside. The smallest electronegativity gets to be in the middle. So let's go ahead and see how many electrons we should have. And you should do that first. Why don't you stop the recording and do the calculation on the electrons. Okay, if you've done the calculations on the total number of electrons in the molecule, this is what it should look like. We have a carbon. The carbon has 5, no, carbon is in column 4. He has 4 valence electrons. And we have 1 of him, so we got 4 from the carbon. Now we have fluorine that has 7 valence electrons because he's in column 7, and we have 4 of him. So we have 28 electrons, 28 electrons from fluorine, and that gives us a total of 32. Now I have how many electrons in the structure right now? 2, 4, 6, 8. I subtract the 8 from 32, and that gives me a total of 24 electrons. And that's how many I'm going to put out. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's all of my electrons. So let's count the total electrons in the structure one last time and see if we get 32. I have 2, 4, 6, 8. And aren't all the fluorines exactly the same? They all have a total of 8 electrons around them. 2 of them are bonding electrons, and the rest of them are lone pair, what we call lone pairs. Okay? So, what do I get with that? 8 times 4 is 32. Well, that's our number. So we have just checked to be sure that we have a total of 32. We do. Now, as I look at each of the fluorines, they're all the same, and they all have 8 electrons around them. And then the carbon has 2, 4, 6, and 8. And that is how we do a good I hope this has helped, and I hope you find that you're able to do these little structures much more easily now. So long. Thank you for watching.